In this video, we're going to learn how to multiply monomials. Remember, monomials are single terms. So here's an example. Let's start with something easy. So let's try to multiply x cubed. That's a monomial, just one term. We will multiply by x to the fourth power. Now, to understand how to multiply monomials, or terms like that, it's going to be helpful for this first example to refresh what it means that x is raised to the third power. What's the meaning of that third power? Well, it means that there is a multiplication that's hidden in this notation, right? So x to the third power, or like anything to the third power, is the multiplication by itself, and I have to have three factors like that, right? So that's x to the third power. And now I'll say times, that's this multiplication here, and then I will expand x to the fourth power. Well, x to the fourth power means that I'm multiplying x, and by another x, and I have four of them, x to the fourth, right? So I expanded each. And now let's look at this one multiplication here, one long line of x's being multiplied. They're all the same, right? So can I write this long line of x's being multiplied by each other using short notation? Yes, I can write that using exponential notation, using an exponent, right? So I have x's being multiplied by each other, so that's x raised to what power? Well, the power that's same as how many x's I have here. 1, 2, 3, 4, 5, 6, 7. So it's x to the seventh power. Now, we won't have to do it every time, but this actually suggests a rule. How can I jump from x to the third power to times x to the fourth power to that answer? Well, what do I need to do with the powers? If I had 3 and 4 and end up with power 7, so what would be the rule? Well, we can probably guess that we have to add powers, right? So 3 plus 4 equals 7. And that's how we will multiply same variables. We'll need to add the powers. Let's try it one more time, and I'm going to remind you about different notation of how we can write down multiplication. So here I use multiplication symbol, right, that dot. Remember that I can also write it like that, n to the sixth power inside the parentheses, and then n to the second power inside the parentheses. And those two parentheses are glued together. So when there is nothing in between the parentheses, it means that we're multiplying, right? So n to the sixth power times n to the second power. Well, now we're going to do it quickly because now we have this rule. So I have same variables that I'm multiplying, then I need to add their powers. Add the powers. So what is going to be power of n? Power of n is going to be 6 plus 2, which is 8. So that will be the idea for multiplying same variables. But now what if we have not just variables but constants or coefficients? Remember, terms can involve both variables and numbers. So for example, what if I have 4x to the fifth power, that's a monomial, multiplied by 2x to the eighth power? Then I have to think of the following. Well, when I'm looking at one of the terms, let's say 4x to the fifth power, what operation is between 4 and x to the fifth power? Well, since 4 and x to the fifth power are glued together and there is nothing written between them, it means that's multiplication operation that's in between them. So that means that I can rewrite it like that: 4 times x to the fifth power. By the way, we're not going to do it every time. Again, we're using this example to understand the rule. We'll do it quicker next time. So 4 times x to the fifth power times, and now the second monomial, 2x to the eighth power, I will write same way. It's same as 2 times x to the eighth power. Now, as soon as I rewrite this product this way, Now I can look at it as the multiplication of 4 factors. 4 times x to the 5th times 2 times x to the 8th. But remember, when we do multiplication, it doesn't matter in which order we perform that multiplication, which means that I can take 4 and multiply by 2, right? I don't have to multiply only neighbors. I can multiply any 2 factors within that multiplication. So I can multiply 4 by 2. In other words, I will multiply numbers and I will multiply variables. Now, when I multiply numbers, that's pretty straightforward, right? It's 4 times 2, that's 8. Now, when I multiply variables, what rule do I use? Well, the rule we just talked about, right? When I multiply x's, I need to add their powers. So it's going to be x to the power of 5 plus 8, that's 13, right? X to the power 13. So that's going to be the result of the product of this multiplication. So long story short, when we're multiplying 2 monomials, we will multiply the coefficients and we will multiply the variables by adding their powers. Let's try one more example. 12m squared, and right next to it is negative 2m to the 4th power. Now let's try to be careful here, and this expression may look a little bit misleading. Every time when we start performing operation, we want to make sure that we're performing the correct operation. Now, what is the correct operation? When I'm asking that, I mean, is it multiplication, subtraction, division, addition? Well, obviously it's not an addition and it's not division, right? But what is that, multiplication or subtraction? Well, here we have to pay attention to the parentheses. Now, negative 2m to the 4th is sitting inside the parentheses, and those parentheses are glued to 12m squared, right? So I have to think that this negative sign comes with this monomial, right? That's part of the coefficient negative 2. But between the set of parentheses in which that monomial is sitting and 12m squared, I don't have any symbols, right? So over here, I don't have any symbols. That means that I will be multiplying. So that is multiplication. For subtraction, I had to have minus right here in between the first monomial and the second monomial. I would have to have sign, but no sign, so it's multiplication. Okay, since it's multiplication, we're going to follow the quick rule, which is multiply numbers using their signs, right? In other words, what I mean is that it's 12 multiplied by negative 2. So positive number multiplied by negative number, it's a negative, and it's negative 24. And multiply m squared and m to the 4th power by adding their powers. So it's m to the 6th power. And here's one more. What if I have negative 2y squared, then 4y inside the parentheses, and 9y to the 4th power? How about that? Now, as I look at this example, I can see 3 monomials, right? The first one is negative 2y squared, the second one is 4y, and the third one is 9y to the 4th. We also can observe that there are no symbols in between those monomials, right? So they're all glued together. It means that that's all multiplication. And we're going to start by first multiplying the constants, the coefficients. So since I have 3 monomials here, then I just have to multiply 3 numbers. That's all it is. So it's negative 2 times 4, which is negative 8, and then negative 8 times positive 9, that's negative 72. Okay, and then I will multiply all variables. They're all the same, so I can multiply them out. It's going to be variable y, but the question is what's going to be the power of y? Well, I'll have to add the existing powers, right? So I'm going to take 2, I'm going to add the next power. Well, what is power of y? Remember, when power is invisible, it means that it's 1. Just y or just x, it means that it's y or x to the power of 1. So when I say I will be adding powers, I will be adding 2 from the first monomial, plus 1 from the second, and then plus 4 from the third one. So the answer will be negative 72 y to the power 7. So that's how you multiply monomials.